Okay, this is one of those robotics stories that messes with your sense of scale. Researchers have created programmable microrobots that are smaller than a grain of sand, and they can move on their own. Let's pause on that. Smaller than sand means we're talking about something you could lose on your fingertip, something you'd normally need a microscope just to see clearly. And yet, it's not just sitting there, it can act. So, what does programmable mean at this size? It doesn't mean it's running a full computer like your laptop. It means the robot can carry simple instructions, tiny behaviors like move forward, turn when you detect a cue, or follow a pattern. And the other word here is the real headline, autonomous. Because a lot of tiny robots in the past were basically being guided from the outside, like remote controlled dust. If you stop controlling them, they stop being useful. But this new direction is different. The goal is, once the microrobot starts, it can do basic decision making on its own. Not smart like a human, smart like a very tiny system that can sense something, choose a response, and move. So think of it like this: sense, decide, move. That's the loop. And getting that loop working at sand grain scale is a big deal. Now you might be wondering, how do you even power something this small? And the answer is, the power budget is microscopic. We're talking about extremely tiny amounts of energy. That's why you'll often see ideas like harvesting energy from the environment or using very efficient movement methods, because at this scale, every little bit of power matters. So why does any of this matter beyond wow, tiny robot? Because once you can build micro robots that can move and follow simple programs, you can imagine them doing jobs where bigger robots can't go. For example, sensing in tight or dangerous spaces, like inside tiny channels, narrow gaps, or complex structures, or micromanufacturing, helping assemble or manipulate very small parts. And yes, long term, people explore pathways related to medicine and biology, but that's still a careful, future-facing area, not a guaranteed next step. But here's the grounded reality. Making a tiny robot move is only the beginning. The hard part is making it reliable, predictable, and safe, especially if you ever want to use lots of them in real environments, at real scale. So the big questions become, how do we track them? How do we set boundaries on what they can do? How do we test them so they behave consistently, not just in perfect lab conditions? And what rules should exist before they're used outside controlled settings? So the takeaway is this: when robots get this small, the frontier shifts. It's not just engineering a cool motion, it's engineering trust. Because micro-robot autonomy isn't a gimmick, it's a platform idea. Tiny machines that can do tiny tasks, with huge implications.